Real.
The Real Real. It's a great name.
Sauce Labs.
Sauce Labs. Thank you. Oh, previous host. Anybody else? All right. In the back.
Google.
Google. I've never heard of that. It's a new one. Interesting name. Yeah. Here, teasing. All right, on to the speakers. First, we have Abe, Joe Beta Ingersoll from, dang, I got the wrong logo there.
Gravitational.
He's from Gravitational, and I didn't update these logos, so I'm going to apologize right now to you guys. It's been a crazy day. And then we have Alex Clemmer. Pulumi. Alex comes to us gracefully from Seattle, flew down today, flying back out tonight, and he is the original contributor creator, can we, of K8s?
Yes.
Yes, and he's going to talk to us a little bit today about infrastructure as code. I'm going to get out of the way. Thank you very much. Again, SFK8s, thank you very much for coming. Appreciate it.
My name is Abraham. I'm actually here all the way from Iowa, and I have to run to the airport to fly home before a snowstorm hits. So it's a little bit about me. Let's see if it's working. The abstract of the title, Serverless, is somewhat of a lightning rod thing. And similar to kind of conference-driven development, or how Kelsey Hightower likes to put it, how he likes to really do something, use something to learn it. This is one of those topics where I sort of, oh, there it is, right? So let's plug it in. Where I agreed to talk about it before I really knew what I was talking about. So this is going to be a very high-level overview. I'm going to fly through a 5,000-foot view, basically tracing my journey in discovery and thinking about this. A bit of background, I'm an SRE by trade. I now focus on customer-facing engineering for a software company out of Oakland called Gravitational. You may have heard of us because we have a really popular Bastion product called Teleport. That's a kind of forensic level man-in-the-middle recording thing for both SSH and also nowadays for kubectl. So if you have people who are trying to make the leap from imperative to declarative, but they still want to do kubectl exec into a pod, come see me and I will be happy to hook you up with Teleport. We also have an open source distribution of, well, it's not really a distribution. It is a certified CNCF thing. We have the practice of doing forward deployed Kubernetes clusters in environments we don't control. So basically we treat it as an appliance. We do interesting things with it because of that. So I'm actually not going to talk at all about our products. So if I say something embarrassing or otherwise stupid, it's not my employer's fault. In fact, my boss is sitting back there, as well as my speech coach. So I don't hear about y'all. I'm nervous about them. All right. So I've done 4 of these meetups now in different parts of the world, and I always start with Kelsey Hightower because he is my idol. I like to call him Sweet Baby Kubernetes Jesus, and lately he's become Sweet Baby Serverless Jesus. And if you listen closely, amongst all the different places he's gone, all the different keynotes he gives, over a very long period of time, he's basically been begging the SREs of the world, or the builders of the world, to simplify, to just focus on value. So this was even just a few days ago, where he's basically saying the definition of serverless is not requiring people to really understand anything except their logic, either the thing that they want to focus on, the thing that they want to do. So besides that, I'm not going to get into what it means, how it works, the plumbing. It's an amazingly broad field, and it means a lot of different things in a lot of different contexts. But in this context, I'm just going to zoom in on serverless on Kubernetes. Now, you do have to start back with the 500-pound gorilla. If there's anyone from Amazon or VMware or Google shit. I have to apologize up front because a lot of these this is a bystander's point of view, basically. I'm not in the muck with this stuff, and so I'm picking and choosing what I take away from this. In this case, it was a talk at startup school down the road in Palo Alto, where 43 minutes in, this guy on the right there, Kyle, who's a software engineer for Y Combinator himself, so he works for Y Combinator, gleefully asked the CTO of Amazon, hey, what do you think of this cool container stuff? What do you think about Kubernetes? And Warner, in this kind of petri dish or fishbowl 43 minutes into this fireside chat, said some very interesting things where you had to like not ignore it. Like, wait a second, he doesn't understand Kubernetes. He thinks it's just this passing fad, and he's basically saying, he's talking his book, like the lock into Amazon or the draw to their nice services is very, very strong. But if you pay close attention to what he's actually saying, he just doesn't understand why we're all geeking out about containers. He sees it as 2 steps back instead of multiple steps forward. And when he says there's enormous pickup around serverless, like that means that there's an enormous amount of meter billing happening that you just can't ignore, right? There's a lot of people who use Kubernetes. A lot of my friends, in fact, one of my friends who I saw at KubeCon directly said this, I don't believe in serverless because serverless doesn't believe in me. I don't need serverless. I need a job in serverless. And this, extremely wealthy Amazon executive who's saying like, duh, the highest growth companies we see are using this pattern and using it very, very successfully. Now, in the middle, you've got Kelsey, right? And I don't know if he practices these things, if he just offhands. He's got brilliant little quips about different aspects of it. And this is, I think, this t-shirt he's wearing is actually a company called Serverless.com based in SF. This was in Copenhagen. Now this was in Seattle a couple of months ago. He literally put 4chan in a container, and he even deployed it to Amazon's cloud, much to the chagrin of Google's marketing people. And then he called across cloud from one serverless function to another serverless function. A truly amazing live demo. And if you read the subtext, you read between the lines, he's basically saying, since very early on, Kubernetes is not the end game. Now, one of these is just the snap of him doing the keynote at one of these Kubernetes conferences. The other one is back in 2016. I was running teams at a Fortune 500, and one of my teammates had bumped into him at a HashiCorp conference. He had recognized the logo of the name of the company, and he offered to come on site and do this day-long kind of debrief, like this is what it is, this is what we're thinking. And he literally just sat in this room and patiently explained to us. And even back then, he was telling us, please do not expose these Kubernetes APIs to developers. This is just not for them. Kubernetes is essentially not the end game. This isn't something you want to make people understand. They just want to. So the amazing thing about Kelsey, besides just he's an awesome individual, and he's one of the best spokespeople we could possibly have for this technology, is that his message has been the same for this entire amount of time, right? So it's the other thing that people don't realize about him, or about the what kind of Google is up to, is this theory of commoditizing your complement, right? If you think Kubernetes is their attack against people just using Amazon stuff directly. And that's kind of what you need to think about when you think about serverless on Kubernetes. It's the kind of natural progression of where we're headed. So when I agreed to talk, I was like, oh shit, what do I do? Where do I start? And if you're in the talk, I was like, oh shit, what do I do? Where do I start? And if you're in the Kubernetes world, it's hard to not trip over the Cloud Native Computing Foundation. And this is this weird alphabet soup or logo soup happening where Dan Cohen and all his kind of nutty professor geniusness has inclusively brought everybody together. So like, let's get your logo on the sheet, and then let's have this path for how we can have people follow this path. Now, what's fascinating is there's even another one for serverless. Like, oh man. So you look at hosted, they're all grayed out because they're not open source. You can't go and actually see how they're done, what they're made of. And then there's a set of installable, see how they're done, what they're made of. And then there's a set of installable ones down in the far right. So you're like, oh, cool, like what are those? And then if you look closely at those, there's these 5 that are actually like amenable, something you can work with. And then of this set, I'm basically just going to go through in a chronological order of which one is what, where it comes from. This has this patent clause where basically it's mutually assured destruction if you start to have patent lawsuits. I don't know why he chose MIT. I would love to actually ask him. And the other fascinating thing is it's a very small footprint, only 5,000 lines of code. Relative, like it's almost an order of magnitude smaller than most of the other ones. And then, like even to join their Slack channel, you have to submit a Google Doc form. He wants to know a little bit about you, and then he invites you immediately to a contributor meeting, like come and help out in the project. So it's also one of the only ones that targets Docker exclusively. And in talking to various end users, people who are kind of container curious or Kubernetes curious or just dealing with the morass of typical enterprise stuff, it's actually really appealing that it is something that doesn't really require Kubernetes to run. Like it will, it's actually serviceable on Docker. So I think this is something that deserves a close look if you want simple, just get up and go. This brings us to Knative. Now, Knative is weird because it came out of left field. It was an announcement at Google Next 2018, back in July or August of last year, and it was really kind of easy to ignore, or kind of like in the litany of other things like gvisor and fascinating other kind of code dumps coming from Google. It didn't register on my radar at all. I was like, oh wow, whatever, it's a cool name. But then when I looked at it closely, I'm like, holy crap. Not only is this thing serious, they endeavor, like they studied all these other ones, and they endeavor to be the thing that the rest of the stuff runs on. And you actually see hints of this in the other commercial offerings. The ones in the CNCF landscape that sort of didn't make sense, or were like they predated Kubernetes, or maybe it wasn't something where it was it wasn't a Kubernetes native experience that I ignored for the purposes of here. They're all replatforming onto Knative. The other kind of fascinating thing about this is it requires Istio, which effectively is a control plane for envoys. So this notion of sidecars, is basically a solution for ingress in a very smart way, but in a way that like requires you to install 36 custom resource definitions on your cluster. So you're talking complexity overload, but maybe that's just inherent in this problem space. Maybe it's something you have to do. And then the other kind of fascinating thing is this one's the only one besides OpenWhisk that has a plausible story around multi-tenancy and around security because of that kind of embrace of Istio. So that brings me to a demo where I will try to show you what the hello world. What I really want to do is try to crash it. So let me get this to where it's viewable. So I, in essence, just followed their quick start, booted up a cluster on GKE because GKE is like the gold standard of Kubernetes. The Google Cloud team still has deep tentacles into Kubernetes as a project. The kind of thing to do is just think, like if you can get from 0 to up and running with a given set of docs, right? That's just a measure of healthiness with the project. This is when I didn't need to do anything except read the docs. It was completely clean, it made sense, and without trying that hard, away I went. Now the other fascinating thing about Knative is they split it up into first principles. So serving is fundamentally different than building, is fundamentally different than eventing, it even is fundamentally different than like monitoring or metrics or other parts, right? When you start to think about first principles of how serverless should work. So in essence, all you have to do, it doesn't really meet that Kelsey Hightower definition of just like not needing to install anything and just being able to focus on your code. But you can see that it's getting really close to doing that. So I come over here and I do nothing more than I apply it. I run my, oh wow. So I applied this YAML. One of these custom resource definitions is serving. It's now got my new code, my new container. It has wired everything up through Istio, and all I have to do is start hammering it. And this is now coming off of a live GKD cluster. If I watch what's happening with my pods, it's magically spun it up, and there's 3 of them running. If I kind of close it down and stop hitting it, the other fascinating thing is it'll scale to 0, right? It'll leave me with nothing running in my cluster, which is one of the first kind of magical things about using kubectl is, how do you restart a pod? Well, you delete it. That doesn't make sense to a lot of people the first time they encounter it. And this is another thing where the magic of serverless is you can really go down to 0, and Knative and Istio combined will boost you back up to not be 0 the first time the request comes in. Yeah, that's about it. The only other idea I had to show was to try to kill it. So in theory, if I maxed out the Wi-Fi here, I could literally do 50 concurrent, let's do 100,000 requests, and it should scale it up. I don't know if it will. I was very scared to do it before the actual go. It's been in the pods. Maybe the actual Go program itself is just efficient. It doesn't, as a vCPU, 4 vCPUs per machine, 8 gigs of RAM. I'm not even able to scratch the surface of the horsepower. It's an expensive cluster. I need to turn it off. That's it. That's serverless on Kubernetes. So if you're a non-believer, if you're someone who's like, I want to have my R610 in a data center somewhere, if you don't believe in a massive Amazon bill, it's coming. It makes a lot of sense that Knative kind of is the platform that serverless stuff will be built on in the future. Like a couple of little hints. It's not, the trademark's still owned by Google, the code's still owned by Google. There's no cloud native foundation. But all that is to come. I think instead of going to Barcelona and KubeCon, we'll be going to Knative Con within the next couple of years.
I think EnvoyCon is for the purpose.
So, where do you see the benefit of using serverless on Kubernetes as compared to using Amazon Lambda, for instance?
It's really kind of, if you're more in the DIY mindset and you're not someone who wants to, basically you don't want to get locked into Amazon primitives. Inherently, if you're using Lambda, you're using IAM, you're probably using some of their stateful services, you're doing the things that are going to be very hard to extract yourself from once you hit scale. So when I was at that same Fortune 500 with a shot of Kelsey, they had built a platform, verified tickets, where the team that built it as an event-based thing, where they were taking the models, kind of all the scans of people entering stadiums and stuff like that, and then making a prediction about who was an actual fan and who wasn't. Their entire thing was built on Lambda. And it was fabulous until they got the bill. And they looked at how much per invocation is this actually costing us. So the reason not to would be to remain nimble. I think that's one of workload portability is one of Knative's single largest goals. So time will tell if we get there as an actual thing, but I think that it makes a lot of sense in the evolution of Kubernetes. The Knative is now kind of where the action will shift to. You'll have a lot of plumbers and a lot of people working and focusing on keeping Kubernetes boring, and all the fun stuff will be in how do you do service meshes and how do you think about container identity or function identity, and how do you successfully run stateful stuff, commingle closely with these stateless functions.
Questions? More?
So I have actually 2 questions. Have you also tried Knative build, actually?
I didn't. It made sense that it's there, but I didn't try it.
So basically, I didn't 100% follow. Basically, the manifest said you applied, you just referenced an existing Docker image, right? You didn't build it. are using the
completely skip the
command.
step. So yeah, I think Knative builds where you can just submit code instead of having to actually build that container.
Yeah, because I think that's also important about serverless, right? Is you want to have your code and just deploy it, and you don't want to have to really deal with Docker as a separate step, so to say. And I think that's what's cool about serverless in the sense that you can do all those things like building the container and deploying in one step. It just hides it for you. But anyways, the other question I had is, do you know the Knative eventing? Does it use a certain persistence layer or something like that, or how would that work?
I skipped over all of it. Alex probably knows.
Why do you think I know?
I'm just the warm up for Alex. That's all I do. Each one takes different strategies about how to handle persistence. So Nats is one of the ways to do asynchronous eventing. So like OpenFast is transitioning to use Nats as something if you want to have asynchronous kind of queue for events. There's also a large set of people thinking deeply about that problem, but the surface area and the complexity in the different areas is super deep. Right? So.
Cool. One more? Anybody? Yeah.
Two questions actually, kind of both Istio related. When you were talking about the kind of headaches with setting up Istio, the GK8 cluster that you spun up, did you use the native ClickBox Istio deployment, or did you have to deploy that beforehand?
I don't know what ClickBox.
There's a checkbox now in the GK8 cluster that just enables Istio.
I think that one's actually, this is all I did, like literally. Well, I had to create the cluster, but it's a gcloud command to create the cluster. That's it, cut and paste from a markdown file. They do have Google Cloud functions that you can run on your own GK8 cluster, but it's in like beta still at this point.
Okay, and then for scaling it down to 0, how is Istio involved in that? Is it just retrying at the sidecar level and basically retrying that request when that does scale down to 0 and waiting for it to come up?
I don't know. But eventually this pod will go away. And then it'll say 0 of 0 ready. It's tunable. The docs on how its auto-scaling work are fascinating. If you've ever had to deal with this stuff at scale, it makes a lot of sense. Yeah, it was just sort of, you quickly get into the weeds of how it fits together. But the sort of fascinating thing for me, as someone who's dealt with this in like prior generations of technology, is that it all makes a lot of sense. Even outside of like the walled gardens of GKE and Google Cloud, it makes sense. So one of the things I really like to do in kind of the next generation of this talk is package this up into our air-gapped Kubernetes installer and actually like say, here's Knative function as a service in a little tarball you can stick on a USB key and put on a carrier vision, send across the English channel, and rematerialize function as a service even in a front closet or you don't control it. Right? It literally, the primitives and how they put it together should allow you to do that.
Thanks so much, Abe. Next up, Alex from Pulumi.
Okay, so I have called my talk "Kube Control is Not Enough: Reliable App Deployments on Kubernetes." Today we're going to be talking about the general space that I think of as infrastructure as code, general movement, our specific approaches to very specific problems in the ecosystem. Before I get into it, I could not help but notice that I used to work at Heptio, and I couldn't help but notice that Joe Beda was giving a talk in the Bay Area Kubernetes Meetup, which is in like Google's headquarters, at precisely the same time. that you guys are here listening to me, and I just wanted to say thank you for showing up to my talk and not his. And I hope you will excuse that I'm actually going to change the title of this talk to What Joe Beda Won't Tell You About Kubernetes. Yeah, okay, all right, so I work at a company called Pulumi. Before I tell you anything about that, I want to start with a assertion, right? So I'm asserting Kubernetes competes with Bash. Actually, should I have a microphone?
Just mics next to the table.
Okay. All right. So I guess that's not going in the recording, which is probably better for my career, honestly. Okay. So. Okay. All right. Does this work? Can you hear me? Okay. Cool. So I assert Kubernetes competes with Bash, and I assert this in a very I mean this in a very specific sense. So it was actually not that long ago that if you were running a web server somewhere, right, it was not frowned upon necessarily for the deployment apparatus to basically SCP a tarball over with your application in it, and then you have like a script, right, that SCPs into that server and untars it and like nginx start or whatever, and that's like your like that is how stuff got shipped back in the day. That was not that long ago, so if that sounds terrible to you, like look how far we've come, right? So Kubernetes it replaces all of this with a like RESTful API basically. Which I don't have to extol the virtues of to you, I think, as people who are probably familiar with Kubernetes. But a thing that I will point out is that all Bash is not replaced yet, right? Like the RESTful API that is Kubernetes gives you the ability to do a bunch of things which are really powerful, but there is a class of things that are actually, I believe, really important that don't fit into this API. And we're in this awkward moment as an ecosystem where we're trying to figure out what the answers to questions are like I have a managed database like RDS, like how do I actually reference that from a Kubernetes application, right? So this is the basic thing that I want to talk about. And that's so sort of the motivation for the demo that I'm going to give. This talk is like almost entirely demos. Is that suppose you, like exactly what I said before, suppose you want to reference a managed database like RDS or Cosmos DB from a Helm chart, right? And if you sit down and you think about what you have to do, there's like a lot of steps, right? You have to provision the database somehow, right? You have to, using some tool, you have to detect when it's finished provisioning, then you have to go get the connection string out of the API somehow, and then you have to interpolate this into a Kubernetes secret, and then you have to reference that in the Helm chart. Okay, right? So this is a huge pain. Something that seems like it should be really easy is really hard in the average case. And what my fundamental question is in this talk is, do we have a more principled workflow that we can use? Is there a more principled answer to this question that does not sacrifice what we like about Kubernetes, which is that it's a declarative API where you say, this is what I want, rather than this is what you do, right? So what is Pulumi? This is the slide where I make my CMO happy. So Pulumi is basically a collection of open source SDKs, where we take cloud APIs like Azure, AWS, Kubernetes, GCP, and we expose them in SDKs through real languages. And you use these SDKs to declare a desired state, right? So the programming model is declarative in the sense that you can't tell Pulumi what to do, you can only tell it what state you want across all of these cloud APIs, right? And you'll see what I mean in a second when we get into the code. But the Pulumi engine, once you declare the state that you want, it will develop a plan, and it will execute a plan to get at the state that you've described, okay? So we cover all of the major clouds, not DigitalOcean, which I don't consider a major cloud. Under this model, so what this would look like is, with Pulumi, instead of doing this series of steps which involve a lot of different technology and probably a lot of Bash, like stitching stuff together, what we're going to do is we're going to write a JavaScript program that declares this steady state, we're going to, in this particular example, which we're going to incrementally build up to, we're going to boot the Cosmos DB instance, parse the connection string, put it into a Kubernetes secret, and then reference that from a Helm chart. Pulumi will take that desired state, it will create a plan, and then it will execute the plan and drive us towards that state. So the rest of the talk is just going to be incrementally building this up. I'm going to start with like basically a hello world example, which does nothing particularly interesting, and at the end we'll have something that looks like what I described. Okay, so the first example that I'm going to show you is just like the hello world example on the Kubernetes help pages, right? So can you guys see this? Does this look okay? Okay, so what you can see here is that we have an SDK where we're saying, we're saying new apps v1 beta 1 dot deployment. This example is like old, but critically the API itself. So the object that you pass to it, if you've ever written a deployment, you know that this is like the deployment shape, right? Like that we're not editorializing the API; it's a direct projection of the API underneath. And what the constructor does is it's like a hard declarative barrier. When you say new Kubernetes apps v1 beta 1 dot deployment, you're saying I want this specific deployment object. I want you to drive towards this specific state, and you can't change it after you call new, right? So the second part of this is we are going to create a service that exposes this to the internet. Again, we're using the service API, and what I want to show you now is what happens like when we actually execute this program. So like, what do we do? I should clear. So if I run Pulumi up in this directory, we will execute the program, we will develop a plan, and then we'll list the operations that we're going to perform, right? So it says we're going to create a deployment, we're going to create a service because we don't have anything in our cluster. By the way, the Pulumi engine is a drop-in replacement for kube controls, so anywhere you have a kube config, we will just pick that up and we will execute operations against the cluster. When I click yes, you can see the operations in real time. And an interesting thing about this is that we've written Pulumi so that the operations are sliced up into fine-grained units of progress, right? So as you're booting up a deployment, it will tell you like, we are doing this. Now we're like, creating the replica set. We have successfully created the replica set. Now the deployment initialization is complete. In the case of the service, you can see that like we're waiting for the public IP address to be allocated by the underlying cloud provider. This is useful because it gives you like, if you've ever like kube control applied like YAML into your cluster and wondered what happened, right? Like in theory, this should be solved by your monitoring platform like Prometheus, but like in practice, I think there's a class of problems that are trivially easy to surface to the user, and that's sort of our goal in this. So we have this notion of, because we have a notion, like a robust notion of resource initialization, we can do things like we can wait for the service to boot up, and then we can export as what's called a stack output, the IP address of that service, right? So if we go back to the program, we see this funny line where we're like export const from an IP, blah, 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 blah. That just is taking the service and exporting the specific value. So if I go to this IP address, it'll say, welcome to Nginx. So that's pretty cool. Okay, all right, so hello world, okay, all right? So just to give you a flavor of what we're about to do. The next thing that I want to show you is an incrementally more complex example. It's essentially the same thing, but with one difference. And that difference is that we are using a config map to configure Nginx. Okay, so Nginx we're going to configure to say, I'll actually show you the default.conf. If you've never seen an nginx default.conf, basically you can tell it, I want you to proxy traffic to this other web address. In our case, we're proxying all traffic that we receive to pulumi.github.io, which is basically pulumi.com. So you see some of the more familiar constructs now, like new config map, etc. The major change is that the deployment that previously ran just Nginx now mounts the config map. what we're going to do is when we boot it up, we will see we'll see basically the same thing that we saw before, but with the extra config map. And then what I want to show you in this example is what happens when you change data inside the config map. Okay, so when I go to default.conf, right now it points at pulumi.github.io. Instead of doing that, I want to maybe point it at google.com. Where else do I have to change it? Here. So if I update this to google.com and I run Pulumi up again, what we will see is a detailed accounting of the changes that happen, and we will see it in terms of the once this finishes, we'll see how this change affects the entire app, right? The app in its totality. So if you think about, if you've never seen this happen before, if you've never updated a config map using Kubernetes, you might not be aware of some of the subtleties of the semantics of this. So if you use kubectl to apply a change to a config map, like you just go into the config map and you change some piece of the data and you kubectl apply it, that doesn't actually trigger a rollout among the pods that reference it. Okay, right? So like basically what'll happen is you'll just sort of slam the new config map definition into the API server, and then the kubelets have like this time to live, and then when that expires, they sync to the kubelet, or they sync to the API server, get the new data out, and they sort of just drop it into the pods on the fly, right? And this is like not what most users are expecting, I think. But most users are like expecting there to be a clear accounting of, like, they expect to process this in terms of the lifecycle of a pod, right? And so like there are all sorts of hacks you can do to get around this. One hack is like you can, like, basically, like when you think about what you want in an ideal world, what you would do is you would create a new config map, then you would update the deployment that references it to point at the new config map, and then once that succeeds, and only once that succeeds, do you finish the deployment, right? So that's like the ideal, right? And people have invented all sorts of machinations to try and get something like this, but with Pulumi it's basically free, because so when I changed pulumi.github.io to pulumi.com and I do a Pulumi up, it will actually show me exactly what it's going to do and in which order. So it says I have this config map, I'm going to replace it, I have this deployment, and I'm going to update it. And if I click into details, okay, we can see what this what the specific steps are, how we're going to change the declarative spec of these resources. So we had this before, where it's like pulumi.github.io, and we're updating it to contain google.com. So we're going to create the replacement, we're going to do a replace operation, and then we're going to update the deployment to contain this new, a reference to this new config map, which is different than the old config map. So I'm going to click yes, and it's going to quickly show you each of the steps that happens when it updates. So here we are, we've created the replacement, we're rolling out the new replica set. When the liveness and readiness probes succeed, that will succeed, and we're done. Okay, right, so what is useful about this model is it gives you a clear view of how an update will affect your application that is running in production, say. And this is super useful because it helps developers who, normally this is like all implicit in the semantics of the Kubernetes API, and by presenting it in this way, we have a clear accounting of specifically which changes are going to happen to the application, and it gives us the power to reason about the blast radius of a set of changes, okay? So so what I want you to take away from this is that the update semantics, like the ability to like plan ahead and explain what is going to happen in a set of changes, is actually useful, and you should try, like we should be embracing this as a community. Okay, so my last example is an example where we do what I said at the beginning of the talk that we would do. We're going to, this is actually a vastly more complicated example than any of those things. So we do a bunch of things in this. So we create an AKS cluster. AKS is like the Kubernetes service hosted by Azure. Because we support Azure's APIs, we create a Cosmos DB instance. Cosmos DB, if you don't know, is like a document store that's Mongo flavored in this case. and speaks the Mongo wire protocol. And then, oh, actually, I should, before I do that, I forgot to show you, to prove that I'm not a liar, and show you what's at this webpage. Oops. Yeah, okay, so it points at Google now, which is what we wanted. I didn't actually show you the you know, when it pointed at Pulumi, so whatever, like, doesn't matter. Okay, so for this next demo, so we're creating the Cosmos DB instance, right? And this is the part where we're doing something in like 30 lines of code that is normally very hard, right? We write a function because this is JavaScript, basically. We are writing a function, parse connection string, and we're passing Cosmos DB.connection strings into it. And the reason why this is interesting is because connection strings is a calculated, it's like a computed value, right? Like you can't get that value until the resource has finished initializing, right? There's no connection string to be had if the Cosmos DB instance doesn't exist. And what we're doing here is we're taking that, we're parsing that, and we're creating data in the like this Kubernetes, just normal Kubernetes secret that the application expects. So it's a structure the application expects. And in this case, the application referencing the secret happens to be Bitnami's like node example chart. You can see the reference to Mongo secrets here. This is the same secret that we have parsed the connection string into. And what's interesting about this example beyond all of that is that this K8s.helm.v2.chart is actually just a library. Like it's like trivial to implement higher level constructs, including fetching a chart from Bitnami's repository at a specific version and passing a set of values in, because it's just a normal language, right? We're just using JavaScript. So when I move over to this window and I Pulumi up, we can see that I've actually already pre-provisioned the Cosmos DB. Oh, I have to log in. So I pre-provisioned Cosmos DB and K8s because they each take like 20 minutes to boot, and we do not have time to wait around for that. So, so what we're doing here is we're only going to be creating the Kubernetes specific resources, basically. So you can see the detailed breakdown here. We have the secret that I was telling you about, and then we have this chart, and as sub-resources of the chart, we have the Kubernetes service and the Kubernetes deployment. So if I click into that, you can see what we're creating. This is nice if you don't trust like infrastructure people to do what they say they're going to do. There's this nice, like if you don't trust like a random Helm chart, it's easy to audit because you get like a view of, like an accurate view of the plan and what resources are going, like what operations are going to be performed on which resources, right? So we're creating the secret, we're creating a chart has sub-resources, service, and deployment. That seems fine, so I'm going to click OK. Now we wait for Azure to boot its load balancer, which is unsurprisingly much slower than the load balancers I booted on GKE. So while we're waiting for that, I think we can probably take questions, but I'm trying to think if I missed anything that would make my boss mad at me. So it's open source, Pulumi, the Pulumi core engine, all of the SDK stuff, everything I've shown you today is totally open source. If you want to go contribute or file issues, we'd love that. Yeah, I think that's all I needed to say.
Questions while we wait?
Questions? Oh, wait.
No questions.
No questions.
That's,
Oh, I see.
That's really good or really bad, I think.
Hi. So you mentioned that, I guess at the start, that you support all of the major clouds, and a lot of the demo has been around like deploying K8s stuff. So I was wondering, does Pulumi's use overlap with Terraform in the sort of like scaffolding general cloud resources, or is it mostly focused around more of this like deployment?
It is very similar to Terraform. In fact, some of our resource providers, like Azure, for example, under the covers, call out to, they use like the Terraform providers underneath the hood. are we focused on? So I'm confused by the second part of your question.
Well, I guess like, is this a superset of Terraform functionality, or or would you still use both tools?
You would definitely not use both tools, I think. I mean, you could, but it would be. I'm not sure if you're already using Terraform or already using Pulumi. I'm not sure what the other has to offer you specifically, except in the case of Kubernetes, where our I mean, I am biased. I wrote the provider, but our Kubernetes support is different in ways that I think have substantial implications for production. So, for example, we support strategic merge and updates, and we are a direct projection of the Kubernetes API rather than a projection to like the Terraform version of the API and stuff like that. Typically, I have not seen a lot of users using both tools. I think.
Okay, so you could use it for all of your just like VPC scaffolding and like.
Oh yeah,
all
yeah,
that,
yeah. That's like a core scenario.
Yeah.
Actually, I just want to say I'm a Pulumi user, and my company used to use Terraform for a couple of months, and we are kind of moving everything over to Pulumi now.
So one main reason is like why I think Pulumi is actually better and can replace Terraform is basically the Kubernetes support is much better because they auto-generate this whole, like most parts of the SDK and supports all kind of resources, whereas Terraform today still has pretty bad Kubernetes support in my opinion. And the other thing is that I just prefer much more to use like Python or TypeScript to write my infrastructure code instead of HTML, which is super complex, or like, I don't know, it's kind of weird, the tooling is not that good to write some instructions and things like that.
So we did hire the original maintainer of the AWS module of Terraform, and one of the things that he told me is that he didn't realize that you could still have a declarative API in a real language before he saw Pulumi, which I think that's like, in my opinion, that's like our core insight. It's like you don't have to sacrifice the declarative aspects of the API, and you can still get a reproducible, plan-oriented experience. So,
Others? Three.
So how complex is the process of keeping these abstractions with the different cloud providers up to date? Like, I feel like, so just the example of Cosmos DB, like Azure API is so complex and crazy. So like, I'm just imagining like what is the level of effort here?
So for Kubernetes, the effort is pretty lightweight because it's open source. So when Kubernetes cut a new release, like 1.13, we had a release supporting all of those features within in 23 minutes. It's not a trivial effort, but it's like in that case, it's like much. It is like so much easier if you don't have to like map through a different API and like figure out all this other stuff. For AWS and Azure in particular, it is incredibly challenging because it's not open source. You have no idea when something's going to be announced. When it's announced, like you have to go find out all of the stuff you need to know to create the initialization semantics, and you have to like write it up. So that is vastly more challenging. But the Kubernetes stuff is pretty easy. So.
Any more? Last call. Are you going to do the?
Oh yeah.
Back to...
Yeah, I should do that. I always forget to do that. Interesting. Right. So if I go, that's fine. I think. What's that? I fucked up the demo. There's no nice way to put this. I have no idea where this URL is pointing. So that is. Oh wait, no. I think this is an Azure error. Azure sometimes takes like a really long time to like get into a good state, and I'm not sure why. Like, I should probably switch to a different cloud provider for this demo because like I can't get it to reliably work. I apologize. I'm also an ex-Microsoft. I'm an ex-Microsoft employee, so this comes from a place of love to my coworkers at Microsoft in the audience. I used to work on like a search engine core, so I very deeply understand the problems they have to solve here. But yeah, sometimes the demo like doesn't work. That's
Yeah, it shows differently.
Are you using AKS?
personally.
For this?
Yeah. Oh yeah. This is a case.
Oh, yeah, we encountered some issues earlier today. Wanna talk?
Yeah, so, I mean, they dropped certain Kubernetes version support, like basically, so I think we were using 1.11.3.
Yep.
And they cut over to 1.11.4 and 5, something like that, and then 3 was just gone.
Okay, so like, why didn't it tell me that at provision time like 10 minutes ago?
Okay, so like if it's not recent, it's probably not that issue, but.
Yeah. Okay. I mean, yeah. If it, yeah. Anyway, I'm.
The Microsoft guys left before we.
Okay. Come talk to me if you
Anything
want,
else?
or don't if you don't.
All right, so we're gonna be hanging out for a while. How long do we have the space?
Until.
No, okay. All right, so hang out for a while. It's 8:10, 8:30. Till 9. So feel free to hang out. These guys are gonna hang out before they rush back to the airport, get on some flights. So
Which airport are you going to?
thank you all very much for coming. Hope to see you next Monday.